Greetings and welcome, friends. Mr. Waddy here, taking a look, a gander, if you will. Just like my eyes are just like taking a bite of our homework and like chewing on it for a while. Like if my eyelashes were teeth for some reason. Yeah, that's what's happening here. We're taking a look at page 103. I'm going to go over a few of these problems here for you. And we've been talking about proofs, more specifically proving statements about like segments and angles. And we've been given some postulates. We've been working with some theorems even for the first time. It's been great. And these proofs are a new thing for us. But the idea is you got to show up to the table with a bag of tricks, your definitions, postulates, properties, and theorems, and just try to assemble them in a logical progression to prove something is true. So let's see. I'll swap out for purple. Yeah, purple. That's a really nice deep purple there. Let's see. So here we got a two-column proof. They're asking us to fill in the blank. All right, so these are like a little bit more hand-holdy. They're trying to help you out before we just throw you to the wolves. So let's see. They said given PQ is equal to RS. So PQ equals RS. Reason for that? Oh, yeah, I'll take it. That's given, my friends. Given. Okay, all right. Let's see. Statement 2, PQ plus QR. So PQ plus QR is equal to RS plus QR. Oh, man, where are they? I feel like they just went like, let's see, RS plus Q. Oh, okay. All right, I was thinking like segment addition postulate stuff already. But no. What they're doing is adding this same number to both sides of this equation if you look at it. Would you look at it, though? Just look at it. Plus QR to both sides. So if I add QR to both sides, which property you guys think that all is? Probably add addition property of equality. And yeah, I'm all about the abbreviations. Accurate, to the point, also efficient. Yeah. Let's see. Statement 3, they said they're going to use segment addition postulate. I noticed statement 4 uses the same thing and made a claim regarding RS plus QR is equal to QS. Okay, so I have a feeling they're probably going to make a similar claim. Let's see, RS plus QR, I'm seeing that. Maybe they're going to make a claim about this side here. I'm thinking they're going to do that and then move something transitive here. Let's see. Let's actually look at what we're trying to prove. PR is equal to QS. So yeah, so I'm gonna, I have a feeling that tonight's gonna be a good night. Here we go. Let's see if we can do this. Segment addition postulate. PQ. Actually, maybe I'll even write it this side. PQ plus QR. PQ plus QR is going to be equal to PR, right? The big segment is equal to the sum of the non-overlapping little segments. That seems to make sense, right? That's segment addition postulate. And then I've got this next one here. And notice this. What do I got? I've got like the transitive train coming along, all aboard. Here we go. I've got PR is equal to PQ plus QR. I've got PQ plus QR is equal to RS plus QR. I've got RS plus QR is equal to QS. So it looks like I could skip all of those and then conclude that PR is equal to QS. So there was like two middlemen on this problem. Did you guys all see that? That's like a chain of logic, a train of transitivity. So we'll call this, let's see, transprop equality. All right, transitive property of equality, because, yeah, this was equal to that, which was equal to that, which was equal to that. Therefore, the first and the last thing are equal. Wow. Yeah, I got respect for this problem. This problem was pretty okay. Pretty okay. Let's take a look at this one right here. All right. Oh, all right. I think I've got this one, guys. I hope so. Whew. Actually, it's pretty similar to what we were just talking about by the looks of things. It says, let's see, name the property that the statement illustrates. See example 2 in case you're stumped. If angle L is congruent to angle M, and angle M is congruent to angle N, then angle L is congruent to angle N. That done there looks like the transitive property. More specifically, the transitive property of what? Transprop of, well, these aren't equal signs. Yeah, trans property of congruence. All right, same idea. Yeah, same idea. We're good. All right, so we're able to identify that. All right, here we go. Question 13, guys. They are not holding my hand anymore. I am scared. Let's see. Let me actually open up my ruler tool. Oh, we're going to make this look so good, friends. Just you wait. I feel like this is like a pinkish hue on this white here. Yeah, I was right there. Let's see. I'll make my 2 columns. You guys feeling this? 2 column proof. You guys already got yours set up. Let's see. Let's hope that the statements are shorter than the reasons. Maybe not. I don't know. Maybe I'll do it 50-50. Okay, here we go. And I'll get this out of the way. This will be my statement. And this will be my reason. Okay, here we go. Guys, I'm scared. Are you scared? This is not even fill in the blank. This is just like blank. This is crazy. All right, I've got a diagram here. We'll fall back on the diagram. Given GFH is congruent to angle GHF. Angle GFH congruent to angle GHF. Student yesterday was talking about the squiggly on the congruent symbol being like Donald Trump's hair. But who knows how many years into the future people will be watching this video, and who knows what they'll think about Donald Trump then. Who knows? Like, either he'll be completely forgotten, 1,000 years in the future, it'll be crazy. It'll be crazy. Seems like a big deal right now, though. I don't know. Wow. But either way, congruence will still be true when I'm applying these properties. The reason this is true, given right there. Yeah, this geometry has survived 2,000 years already, 1,000 years in the future. It'll still be true. It'll be great. So let's see. They want us to prove EFG and GHF are supplementary. Let's first of all label what we've been given. GFH, so GFH, this angle right here, is congruent to GHF. All right. Ooh, wow. Guys, I'm already pumped about this. I can't wait. Wow. I'm so excited. So let's see. They are claiming that we want to prove EFG and GHF are supplementary. Okay. All right. Are you feeling it? So let's see. I've already labeled my given information. Have we done linear pair postulate yet, or is that today? No, we've done, okay. All right, we'll get there, we'll get there. So let's see. Given this, if the angles are congruent, let's say that their measures are equal. You guys buy that? You remember the reason that's true? If I switch from congruence to equality, I did that using def of Cong, definition of congruence. Okay, so these two angles, measures, are equal. Let's see, how about, here's a claim that I'm pulling from the diagram that wasn't listed as given, but I'm going to say that angle EFG and angle, let's see, I'm trying to prove something about supplementary, so let's start by labeling some things supplemental that we are aware of. And let's see, EFG and GAFH are supplementary. The reason that's true is according to this diagram, this is what, like, yeah, you guys got to be familiar with now, like even how you can use some of these things. But definition of linear pair. I think today in today's lesson will be get you a shortcut to this one here. Let's see. So if these are supplementary, I believe I could then say, what about their angle measures? A measure of angle EFG. What does supplementary mean? What do their angle measures do? They add up to 180. So these angles are not, their measures are not equal. They add to 180 degrees. Okay? So that is definition of supplementary. So you didn't even realize you could use some of these definitions. Right? Good stuff. Good stuff. Okay, so if these add up to 180, does anyone see something I can do that's going to get me closer to my conclusion? Let's see, for my substitution, I usually use the light blue, the turquoise. Let's see, so, how about this? Oh. Are you guys feeling that? If these two things are equal, I can substitute them at any time. So I'm going to say the measure of angle EFG plus the measure of angle GHF is equal to 180. The reason that's true, subs prop. Technically of equality, but in that case, it doesn't matter. And now that I've shown that these two measures, this guy and this guy, add up to 180, I believe we can conclude that angle EFG and angle GHF are supplementary. And the reason that would be true is I used it backwards over here. I'm going to use it forwards here. Definition of supplementary. Right? Not that bad. Not that bad. So remember, definitions are biconditional. I can use them forwards or backwards because their converses will also be true. All right. All right. Let's see. Let's talk about our friend here. I don't know about you guys. Me and my buddy, we were making an argument the other day about question 18. We were probably at Brugger's Bagel Place or something like that, I'm sure. It's where all the mathematicians hang out. It says, in this figure, SR is congruent to QB. CB. I was just thinking quarterbacks for some reason. SR, right, is congruent to CB. All right. And AC is congruent to QR. All right, I believe it. Your friend claims that because of this, CB is congruent to AC. CB is congruent to AC by the transitive property of segment congruence. Is your friend correct? Let's settle with that first. Is our friend correct? No, I'm getting some head nods, no, or head shakes. We agreed on that the other day. Shakes are for no, nods are for yes. I think so. I'm getting a consensus. The answer is no, because my friend's always wrong. But also, the reason that that doesn't work is because I proved that I know that these two are congruent to each other. I know that these two are congruent to each other, but I don't have a middle link for that chain, right? I can't connect those things to one another. So I don't know. I know that I have two pairs of congruent sides, but I cannot relate those pairs to each other just yet. It's possible they were, but with the given information, no. So if I knew this to that and this to that, yeah, there's no middle chain, right? Like if I tried to work this way, SR to, yeah, there's no SR over here. If I tried to work this way, CB, there's no CB in there. Transitive property does not apply. The book's answer is the statements have to have one segment in common in order to use the transitive property of segment congruence, theorem 2.1. But in this case, the statements are about 4 different segments. They may or may not all be congruent to each other. Meh. All right, well, thank you for watching, Internet friends.